Great. Well, good evening, everyone. Thank you to tonight's Microsoft 365 Meetup for Government community event. I'm very excited to have all of you. I think we've got a great session and speakers for you tonight. So hope that you will enjoy it and learn a great deal. For those who don't know me, I'm Nick Giard. I work with Microsoft as a technical specialist for Office 365. If you're interested in adding me on social media, feel free to use any of these links. But I really want to focus on tonight's agenda. So after these, the kickoff and these announcements, we're going to have our first guest speaker, Dwayne Barb, who will introduce himself when he gets started. Dwayne is also with Microsoft and is a identity specialist, one of the best that I've worked with. So he's going to kick us off, followed by Matt Nevins from Planet Technology, who will kind of continue the discussion about identity and zero trust. And then we'll wrap up with kind of a open mic Q&A for anyone who wants to ask questions, make comments, or share information. And then we'll just close out tonight's session just before 6:30. For anyone who can't make the session, it will be recorded and posted as well. So for anyone who is new to our group and our community in these events, this is all about really connecting people who have an interest in Microsoft 365 and the related technologies within what we call the modern workplace at Microsoft. And it's really intended to be a space for collaboration, information sharing, networking, and professional growth and development. And I'd like to remind everyone of our kind of community standards, which are pretty simple, really boil down to be respectful and professional. Don't share anything you shouldn't. This certainly is a group for networking, and we encourage people to promote relevant content that's of interest to them, but please be judicious in what you're sharing. And then lastly, and very importantly, any of the positions or information or topics are kind of reflect the individual sharing them, not in their official capacity, especially as it relates to Microsoft. So we certainly want to make sure that there's relevant and high quality information, but this is really a community event for learning and networking. For those of you who've not used Teams before, this will be a moderated session just to keep things running smoothly. So if you're not familiar with it, a couple of the important things is you can use the little smiley face with a hand to raise your hand, and one of the moderators, as soon as possible, will get around to unmuting you so you can ask your question. And additionally, if you need any other help with Teams the device, feel free to put it in the chat, and somebody will try to assist you. We also have some other great events that are coming up on our calendar, and we're working on adding many more. So in 2 weeks, February 23rd, we're going to have a great session. You own Microsoft 365, now what? Kind of really talk about how organizations can, build their own roadmap to take a maximum advantage of the tools that are in Microsoft 365. So looking forward to that. And then very excited to announce we will be having a special celebrity guest speaker, Renee Wynn, who recently retired as the CIO of NASA. And so she will be sharing some of her thoughts and perspectives on March 9th, followed by kind of a open Q&A. So extremely excited. That is a talk that you're not going to want to miss. So hope that everyone, if nothing else, is able to join us for that session. It's going to be amazing. Also, equally importantly, is these sessions are really driven by the community and content that you guys want to share. So please, if you have, it could be anything from work that you've done, a technology that you're interested in, lessons learned, really whatever it is, as long as it's relevant to Microsoft 365 and the government space, we'd love to host you sharing and being a presenter. So please use this sign-up form to share your interest, and we will be happy to contact you and get you signed up with a session. We've got several folks who are already have expressed some interest, but we definitely want to be as inclusive as possible. So please definitely to take advantage of this. And then also very important for both tonight's session and other sessions, please provide our speakers feedback. This allows us to make sure that we're targeting and improving the content for the group, and feedback is really a gift. So it allows the speakers both tonight and other nights to kind of continue their professional development and continue to improve. This may not be Toastmasters, but it's also a great opportunity for everyone who's presenting to continue to work on both their presentation skills as well as making sure that the content is as high quality as possible. So without further ado, I'd like to turn this over to our first speaker of the evening, Dwayne Barb. So Dwayne, if you'd like to come off mute and take it away.
Good evening, everybody. Thank you, Nick, for that introduction. My name is Dwayne Barb. I'm a technical specialist with Microsoft. I cover our security and compliance products, which include identity, Azure AD, all the EMS suite, and our threat and newly emerging compliance product set. So tonight, let me go ahead and share my deck here. I wanted to talk to you guys about some identity protocols that are in common use today, and what kind of role those protocols and the advantages and disadvantages of them kind of bring to the modern authentication story. So tonight we're going to be talking about what's the most common set of identity protocols in what we typically call hybrid identity scenarios. Define which one of those protocols to use in various scenarios, and just kind of go over OpenID Connect and OAuth 2 as part of instrumental fabrication in a zero trust story, and we'll take it away from there. Okay, so first I'd like to do some level setting, and I realize that this is kind of going back to basics, but I find it's very helpful. So when you look at the modern authentication protocols, they almost always ride on top of the HTTP protocol.
Hey Dwayne, before sorry to interrupt, before you dive in, do you want to share your presentation just so folks who may have small screens can see a little better? Unless you have, will that work if you put it in presentation mode?
So I thought I had it in presentation mode.
It's at least I think we're still seeing the PowerPoint, not the
okay.
If you've got two screens, it might be sharing to
I only have one screen up, so
okay. Well, I don't want to derail. Just wanted to make sure everyone could see clearly. So.
Okay. So it's kind of like if someone wants to raise their hand or comment in the chat, whether or not they can see the presentation or if they actually see it in presentation mode. I kind of want to get a feel if I just need to.
Yeah, we just see the editor, so maybe just take it out of presentation mode and put it back in.
Yeah. Okay.
There we go.
Okay, so are you seeing it in presentation mode now, or are you still just seeing the editor?
Nope, just seeing the editor still.
Okay, so how about now?
There we go.
Yep, you're good.
Okay.
All right. Sorry for the interruption. Just wanted to make sure everyone was getting the best experience. So back to you.
Gotcha. No worries. Okay, so back to what I was getting around to first, the HTTP request, or the fact that these modern authentication protocols use HTTP. Just a little bit about some basics about HTTP, and again, I apologize if this is going a little bit too regressive for you, but basically, in the HTTP world, we have what we call user agent, or is typically seen as the browser, but there's lots of things that can be user agents today. Basically, it's a way of identifying the application that's making the request. HTTP is generally it is plain text over TCP, and the language that it speaks is basically a verb and a resource. And getting into the guts of the request, as you can see here on the screen, the get that's listed there is the verb, and then we have the resource that it's requesting. In this case, it's just asking for the default document at the root of the application or site. and then finally get to what protocol it is, whether it's what version of HTTP it wants you it's trying to negotiate to speak to the resource with. Okay, so the response that you see come back from that is also got various parts to it, and you're going to see the response code. So it's acknowledging the protocol that was used. The 200 response code means that, as the letters indicate after it, it says OK, means that yes, I've located the resource and here is the resource. It gives you the content type. Gets into all the sections in the header here. You got the content type, the last time that content was modified, the tags, what server platform it's on, the date, and how long how big the content is, in fact. And then you get into the body of the request itself. So this is the actual content that you would see. Okay, the post verb is a way to send data to the web server. As you saw in the previous example, get was requesting data from the server. Post is where you're actually sending that data to the server. And the data is URL encoded and is included in the request body. As you can see here, so there's a post going to this index.html location. It's got the content type set to URL encoded. And it's got the value of what you're sending in that body. Okay, an HTTP redirect basically tells the browser where to find a resource. There's lots of situations where if a web request is made for a resource and that is not the actual location for that resource, and the service is aware that you're looking for something, but it's not where you're looking for it, it's going to respond with a certain type of code that says, hey, it's not here, it's over here. So you'll see that 302 response code, and you'll understand why this is important when we look at the way these authentication protocols actually work. As you can see in the header of the 302, the location header indicates where the actual resource is compared to where you requested it. URL fragments are also important, and this is something that not too many people know. When you see that hashtag symbol in a URL, and that's an HTML fragment, and it basically indicates that you want to go to a specific location within a page, kind of to be able to go target a certain area of the page rather than pulling up the whole page just at the top. It's a way to target something to a specific location. Okay. So now that we've got some of the level setting and basics out of the way, let's talk a little bit about tokens. There are lots of different types of tokens used in authentication protocols today, and they all come in different flavors. There's SAML, the Security Assertion Markup Language. It's XML based. It's very descriptive metadata. And that's an important distinction between SAML and some of the other protocols, is the descriptiveness of that metadata. Then we have the JSON Web Token. It's more easily human readable. I would kind of argue with that, but that's generally the consensus. The token size is smaller than, say, like a SAML XML based token. And you have simple web tokens. We don't see those very commonly. They usually form encoded attribute value pairs, which is almost identical to what a JWT is. But like I said, it's just not as common. And then we have our old favorite, our three-headed dog, the Kerberos tokens. Those are a little bit more opaque, not as easily seen or peered into. And then, the last point about tokens is really that there are some protocols that are token agnostic, which means that you could go, the service could, or the authentication protocol could send a token in the SAML format, which is XML based, or it could use a JWT. It could use either one. It really doesn't care at the end of the day which token format is used. Okay, so let's kind of look at SAML assertions versus JWTs to kind of give you an idea of what we mean by the SAML is a very heavy and descriptive type of token compared to JWTs. So on the left, you have a very common, although it's a very small, SAML token, even though it's small, and it really is just listing a couple of attributes. It's not even got a full set of attributes that you would normally see in a normal user authentication. You can see it's very descriptive. It's got a lot of formatting and syntax. Compare that to a JSON web token, which is on the right, and you see the the areas are like 3-letter designations. It's more like a hash table. It's a attribute key or key and key value type of token format. So it makes it a lot smaller. And I guess just the fact that it's very simple makes it a little bit more human readable than your typical SAML token. So now let's go into some details about a lot of the or several of the different authentication protocols, starting with the one that was really first or kind of first on the scene when it comes to modern or what we call federation technologies is WS Federation. It was developed by basically an industry consortium. It was released in December of 2006. Microsoft was a key contributor in that ecosystem or that consortium, part of an overall larger framework called WS Security. And this was back in the heyday of basically SOAP, or the Simple Object Access Protocol. Lots of very thick and very heavy messaging. So they built a security layer for SOAP, and WS Federation was, in fact, a part of that, or at least that's where it had its beginnings. And it builds on the work of WS Trust, which is a subset of WS Security. Basically defines the protocol for requesting and receiving security tokens, defines how that trust should be brokered between parties via a security token service. Today, some common terms, security token services, kind of, I don't want to say synonymous to identity provider or IDP. Security token services would be part of an identity provider that its job is to fashion or mint or create tokens, and the trust that is relayed between parties based on those tokens. It defines 2 basic profiles, the active requester profile and the passive requester profile. And basically what that means is the passive requester profile is the more common thing that you see in today's technologies. It works kind of similar to the way Kerberos works in the fact that the client makes a request to the application to access a resource. The resource says, hey, client, I need you to authenticate. So it tells the client to go to the IDP or the security token service to authenticate. And guess how it does that? It does it through the HTTP 302 redirect. So it redirects the client to the identity provider. Identity provider authenticates the user, generates a SAML token based on the parameters of the predefined trust between that application and the identity provider. And then that token then is sent back to the user or the user agent, and the user agent then posts those contents to the application to consume. There's a lot more to unpack in there, which we will here in a little bit, but just wanted to kind of describe what a passive profile would look like versus an active profile. An active profile is more of, it's just a single request that's kind of sent to the identity provider from the application. So there's no real redirect from the client to the identity provider. It's more the client makes a request. It provides the credentials to that client or to that application. Then the application then spins up the request to send to the identity provider, authenticates it, and gets back a token At that point, the user's not really a middleman in that interaction between the application and the identity provider.
Hey, Dwayne, I've got a question
Yeah,
for you here. So when we
sure.
talk about these sorts of protocols, WS Federation or WS Trust and JWT and SAML and those, are these, you know, I know that there's a kind of distinction, but are these authentication protocols or authorization protocols? Because I know certain ones like you know, clearly like a JWT is really more of an authorization, right? But some other one, but it, you know, in terms of actually identifying the user, that's usually happening for one of these tokens to be issued. Is that correct?
Well, in a sense, yes, and in a sense, no. Just kind of keep in mind that a JWT is a token format and is used by many protocols that can be used for authentication or authorization. So I think it really is the intent of the service and what the protocol is. WS Federation, for instance, is primarily an authentication protocol, or what they call a protocol translation service. User usually provides credentials, and that could be user typing a username and password, supplying some type of token themselves, like a smart card or a YubiKey or some other authentication credential to that provider, and then it translates that into a language that the application can understand and consume.
Okay, so these protocols are kind of how whatever that information is being communicated between systems or machines, but in terms of whether it's just an authorization payload or whether it's actually some sort of authentication traffic, that really depends on how it's being used by the
Yeah, how
system.
it's being used and the protocol itself.
Okay.
Right. So there's no authorization framework within WS Federation. It's just
Okay.
authentication.
That makes sense. Thanks
Right.
for clarifying.
Yeah, and SAML is the same way. I mean, you can use it for authorization things, like some identity providers do give you the capability to configure authorization rules based on information that is present within that authentication session to decide whether or not it's even going to generate a token for that user, right? But at the end of the day, it's just considered an authentication mechanism, and I'll call it that distinction in the protocols as we go through them. But thank you for asking that question. That I'm sure that helps clarify a lot of things. Okay, so WS Federation is the protocol here that is token agnostic. It is unlike SAML. The token can be anything really that's supported in WS. So it could use a JWT, an SWT, or an actual SAML formatted token. Okay, so here's kind of like a little walkthrough diagram or a flow, an authentication flow of what the passive requester profile looks like. So you have your user, your web application, and your token issuer or identity provider. So the first step is there's a trust that's established between the application and the token issuer. In most modern day implementations of this, that trust is brokered through a PKI relationship. There's a token signing certificate that's configured on the token issuer that it makes the public key of that token signing key pair available to the application or known to the application. And the idea is that when the token issuer mints a token to send to the application, it's going to sign that token with its private key. And then when the application ingests or consumes that token, it's then going to validate that signature against the public key that it knows that that was shared between the token issuer and the application. Typically, you see that as a one-way trust between the application and the identity provider or token issuer. There are things in the protocol to make that a two-way trust, where the application itself also has a key pair. It makes the public key available during that trust relationship establishment, and then when it sends a request or redirects the user with a request back to the identity provider, it also can sign that request, so the identity provider can say, hey, this is a valid request from an application that I trust. So after the trust has been established, the user would open up a browser, go to the application. The application says, hey, you're not authenticated, so I'm going to redirect you to the token issuer. The user automatically browses to the token issuer based on that redirect command or directive. The user authenticates to the issuer, and then the token gets generated, sent back to the user, and then the user then posts that token back to the web application. Basically the flow I described before, just now in a very pretty format for you to look at. Okay, so that's all pretty simple, right? So that's a basic passive requester profile, and I can also tell you right now that SAML pretty much operates the same way. There are a couple of exceptions to that. It depends on whether or not, well, let's say for instance, WS Federation supports what they call IDP initiated sign-on flows. And that's basically where the user would go directly to the token issuer instead of going to the web application first. And in that request to the token issuer, there's parameters passed in that request that basically tells the token issuer, hey, this user is trying to authenticate for this application. And the token issuer has values stored in its configuration database for that application that tells the token issuer, hey, once I've authenticated the user and I've generated and signed the token that I want them to use to authenticate to the application, I know where to send them in that redirect. So you can think about IDP initiated as a little bit of reverse of the flow that you're seeing on the screen now. Versus an SP or service provider initiated request or relying party initiated request. Okay, so let's get into the SAML protocol here a little bit. SAML 2 overall overview is security assertion markup language is preceded by SAML 1.1. It was ratified in September 2003. It really only supported two scenarios, or also known as profiles. Both scenarios were IDP initiated, as the flow I just got done describing. Organizations then looked at some of the gaps in SAML 1.1 and started extending it to address those gaps, and that is what caused the genesis or birth of Shibboleth and the Liberty Alliance. And that kind of got rolled all up into the overall SAML 2 specification that was ratified in 2005. It did incorporate the Liberty Alliance extension and others. For example, some of the now Shibboleth is still out there. It's very prevalent, especially in the education sectors. We see a lot of Shibboleth going on there. So it's still a viable protocol, but it's so closely related to SAML that people rarely don't throw a distinction between those two. It did add a lot of features over SAML 1.1. And would love to dig into exactly what all those features are, but we're kind of trying to stay high level on this particular session. So some of the core concepts in SAML 2 and some of the languages say different in the way it's described as compared to WS Federation or any other protocol. So you have assertions, and assertions are basically a package of identity information, and it's synonymous with the word token. So you'll hear people say assertions in the SAML world, whereas everything else, WS Federation, OAuth, OpenID Connect, you may hear the word token. Usually you can just kind of interject those two in a conversation with someone that knows all these protocols, but it's kind of important to know that it's just kind of synonymous there, assertions and token. It's XML based. It contains statements. So it's a declarative type of a paradigm within the framework of the assertions or the token. there's the concept of protocols. There's a request and they're request and response based. It actually defines the messaging requirements. Examples would be an authentication request versus a single logout request versus artifact resolution. Just kind of go over some of these, like I'll pick artifact resolution as an example. Artifact resolution is the idea where people are really anxious about the amount of privacy data that may get transmitted in a token, and the fact that the user's browser gets a copy of that token before it sends it to the application. Samuel came up with this concept of artifact resolution. And what that really means is that when the user authenticates to the identity provider and it mints the SAML token, it's basically only going to include an identifier in that token. There's going to be no other PII or identifiable data in that token that says, hey, this is user X with this email address and this phone number and all those kind of things. It's just going to have a randomly generated ID.
Hey, Dwayne, we've got a question from the chat here just to call it to your attention, which is, could you give examples of when we would see this, or better yet, the protocols that Microsoft uses in its services?
Sure. Absolutely. That's a great question. And that's part of the objectives of this is kind of identify when you would use. And a lot of times what your applications have the ability to support is going to drive or dictate which protocol you use in combination with your identity provider. Obviously there has to be parity between those two or consensus between those two on which protocols it can support. SAML is so in our products today, we mainly have two identity-based products. We have Azure AD, and then we have Active Directory, which is extended by ADFS or Active Directory Federation Services. So everything I'm going to discuss and go over today is supported by both. Both support WS Federation, both support SAML. Today, if you have a federated relationship with your on-premise AD with Azure AD, it's what we typically call a hybrid identity configuration. That trust relationship between ADFS, or even if you're using a different identity provider on-premise, they're going to be WS Federation SAML based. Applications that use Azure AD as its primary identity provider, such as Office 365 Suite, use OpenID Connect and OAuth 2. Azure AD has the capability to provide, single sign-on to, thousands of applications out there. A lot of those are SaaS-based. Some of them are more line of business based, but it supports all of the protocols. So it can authenticate people and get tokens created for logging into an application that may only support OpenID Connect, or it may support SAML or WS Federation. And we even do things like Kerberos constrained delegation to apps that only speak Kerberos. We also provide header-based authentications for those older applications that only support HTTP header-based authentications. So where you would see them used or what protocol you choose is highly subjective based on all your parameters. Okay, so getting back real quick so I can finish up the artifact resolution thing. So you got this SAML token issued by the identity provider that's got a key. The application consumes that token, sees that it's got a key in there, and the fact that it was sent, artifact resolution wise, the application says, okay, I still don't know who the user is. So it generates its own request to the identity provider and sends that key to the identity provider. The identity provider then returns a token to that application containing all the user information in it. So that token that contains all the user information never goes back through the user's browser and then to the application. So just an idea of what the different types of request and response based messaging requirements are defined within the SAML protocol. And then last, you have this concept of bindings. It associates a message, a protocol, so to speak, because if you think about protocol and what it means, think of a Star Wars example. You had the protocol droid C-3PO. Its main job was to talk many different languages and be an interpreter. That's all what protocol means from a technical perspective, is you're defining rules on how to exchange messages or information between parties. So the binding associates the message protocol with the transport, how that message is being delivered. In this case, you have examples. It's whether it's an HTTP redirect binding, or it's an HTTP post binding, or whether or not the binding is SOAP based. Okay, so someone had a question. I heard open mic. No? Okay. All right, so let's talk a little bit about some of the SAML2 profiles. It describes how assertions, protocols, and bindings combine to form a scenario. So if you take all those things that are just described in those three blocks, they all kind of combine to drive, to basically drive a use case. So let's take, for example, the web SSO or single sign-on profile. It uses the authentication, AuthN, compared to AuthZ, which is authorization. AuthN request protocol. It uses an HTTP redirect binding at the assertion point, which is the identity provider. It uses an HTTP post binding at the service provider. Now, a little bit about terminology on you hear service provider, you hear identity provider. Some articles you'll see things labeled as a relying party versus a token issuer. So IDP equals token issuer, service provider or SP equals relying party, which equals basically the application that you're trying to access. SAML profiles. You have the SSO profiles, which is one of the ones we just went over, is the web browser SSO profile. The enhanced client or proxy profile, identity. I'm not going to read all of them off, but there's name identifier management profile, artifact resolution, assertion query request profile. There's a whole list and slew of profiles that SAML 2.0 supports. Okay, the SAML web SSO profile and how it relates to, let's say, WS Federation. It's very similar to the WS Federation passive requester profile. Where it becomes incompatible is that it uses different protocols. It uses different request and response messages. So it has an IDP initiated use case, and it has an assertion query profile. So if you look at a SAML 2 authentication request, this typically, if you looked at it from a like a web browser perspective, this would be a base 64 encoded blob that's sent as a query string to the identity provider and the URL. Compare that to WS Federation, and all its parameters are just typed out in basically a key value pair kind of format as part of the query string going directly to the identity provider. So right off the bat, you can see there's an incompatibility between the way it kind of handles the request and response. Okay, so that gets us out of the SAML 2 and WS Federation world. And now we talk about one of my favorite worlds, which is OAuth 2. OAuth 2.0, just from an overview perspective, is a delegated authorization to APIs primarily. Its main purpose is to get the client an access token. It was preceded by obviously OAuth 1, which was published in 2010. Very heavy, very complex, required a ton of digital signatures, Didn't have a lot of adoption, basically due to how complex it was and the reliance on a lot of PKI infrastructure. Because if you implement digital signature, technologies and encryption technologies correctly, you have to have a very robust PKI infrastructure to support that. When they came out with 2.0, they wanted to slim things down, make it simpler. So they removed the need for a lot of signatures, with some of that starting to creep back into the spec now, actually as additional RFCs, not as part of the core OAuth 2. But it's removed it at the onset. They removed a lot of the signature dependencies, and really started relying more on the security around the transport layer, the security of the communication itself. And that's how you're seeing some of the signature requirements either being addressed or starting to creep back in different formats. There's a couple RFCs out there that talk about HTTP signing as a way to guarantee integrity and deal with some other security issues that have been brought up over time. The whole transition between 1 and 2 was really wrought with controversy. A lot of people saw OAuth 2 as insecure. Aaron Hammer resigned the role of the lead author and publicly spoke out against OAuth 2 in July of 2012. If you look at the URLs in here, I haven't checked them lately to see if they're still up or valid, but if you're not, provide feedback on the forum, and I'll do my best to locate where these things are located. Now, it's quite an entertaining thing to listen to and watch. Aaron's a very articulate person. Dick Hart from Microsoft took over the editor role and actually brought the specification to the publishing point, where it became born as an official RFC. Okay, so when we talk through OAuth, the language starts to change a little bit, and this is where things get confusing for a lot of people. And it for a long time it used to trip me up, because some of the terms used to describe the different players in an OAuth scheme didn't mean the same thing that they meant in other protocols. So clients or applications access a service on behalf of a user, right? So if you look at it here, you have a user, John, a client application, and then a web service. There's two types of apps. There's public apps that run locally on a device, not really trusted to hold a secret, which that would describe what's in the red box now, the client application and the user John on John's device. Then there's private applications that typically run behind firewalls, and the communication paths are more secure. There's more inherent trust in that scenario, and it can be trusted with secrets. And that's the box that, it kind of shifts over to the right. So private client type would be the application, and then the web servers would both be on a web server. They don't have to be, but in this case, this example is just showing that they are located on the same server. So looking at the various roles, so let's kind of look at a typical scenario here. We have an app running on a phone or a smartphone, and we have a user of that device. Then we have some of the data that belongs to the user in this API or service that's on the internet. And then we have Azure AD as the identity provider that application uses to authorize data access. So in this kind of flow, you have John accesses the app on his device. He then gets asked to authenticate by Azure AD, and you'll see this scenario on mobile devices all the time. I'm sure you see it a lot and you don't pay a whole lot of attention to it, but the first time you install an app, it usually has what they call consent prompt. It's going to say, hey, this application is requesting to do these things on your behalf. And it's going to list a bunch of things that application wants to do, and you have to consent. That means you, the user, the owner of the data, is providing your permission for that API or application to access your data as you. Once you've authenticated and provide consent, then the identity provider or authorization server will send a token to the application on that device. Then that application reaches over to the API or service and says, hey, give me that data. And by the way, I've got permission to act as John. So think of it as like from an authentication and data access perspective, this would be equivalent to a power of attorney in the real world. So these labels, John is not the user, he's the resource owner. So that's kind of an OAuth term. Then you have the client, which is a combination of the device and the app running on the device. You have the resource server, which is the application or API that the data is being serviced up through. And then you have the authorization server. So as you can see, sometimes a lot of people, when they talk just everyday normal language, especially if you have depth of time in the IT circles, when someone says the word client, you don't typically associate that with an application. Sometimes you do, depending on the context. And it just it causes me to pause sometimes and trips me up a little bit. I typically use client and user as a synonymous thing, but in the OAuth world, they're distinctly separate roles. So the different flows that are designed into OAuth defines the process for obtaining an access token. There's primarily 4 flows defined in the spec. I'm running out of time here, aren't I? 4 flows defined in the spec. There's the authorization code flow as a one-time code issued to the client or application. The client redeems that code for an access token. So basically, once the user authenticates to the service and says, hey, I give this application consent, then the application says, okay, authorization server, this client has authenticated, or this user has authenticated. Now I need the access token, so I'm going to send you my code, which is typically, if you think about it, that code is like one vector of trust between that client and the authorization server. There's a client credentials flow, which authenticates the client, not the user. So the app itself is what authenticates, not the actual user. The client receives the access token for itself, not on behalf of the user, but it receives that token for itself. Then you have the resource owner password flow, which your client or application collects the user's credentials, exchanges those credentials for an access token with the authorization server. And then you have the implicit client flow, which is a client which is public or untrusted. There's no refresh token issued, and that's kind of one important distinction between OAuth and the other protocols, is typically you see 2 tokens issued in those flows. You have a long-lived refresh token and a short-lived access token. Meaning the access token is what is used to gain access to data, and that token typically can be very short-lived, definable based on platform, but the most common configuration I've seen is 60 minutes for the access token. Then you have a refresh token. Refresh token is kind of like a single sign-on mechanism, kind of, sort of. But it's something the authorization server gives to the client that basically says, or the end user, whatever user agent you're looking at, and it is a way for it to go back to the authorization server and request new access tokens or access tokens for different resources without the need to type in their credentials again. It's very similar to the Kerberos authentication flow, where Kerberos issues the client a TGT or ticket granting ticket when they authenticate, and then when they go to access a service, the user uses that TGT to say, hey, this is me, you authenticated me already, I need access to this service. The key distribution center in that case then says, hey, I know that service, so I'm going to send you a TGS, or basically a service ticket that will unlock that application for you or get you access to it. So Nick, I'm running out of time here, and I got about 10 more slides to go through.
Yeah, it might be. I mean, Dwayne, if you want, I mean, we can poll the audience here quickly. I mean, is there other, because we've got a little time built in for Q&A. So I mean,
Okay.
I think that's fine to eat into that. But if folks want to kind of keep going through, based off of who we have, like some of the specifics of OAuth, or if there's some other kind of flows that you want to talk about, we can jump to those too. So just leave it up to your judgment, Dwayne.
Okay. So let me just kind of quickly blow through these, and if I go too fast, then I can address some of the things in the Q&A, because I want to give our Planet guy, because this conversation kind of dovetails into what he's going to present very well. So quickly, the authorization code flow summary. The concept is the client gets an authorization code first. The client then uses that code to redeem and get an access token. This is best used for private clients, web applications that, the behind the firewall on the same server, someplace that you control and can trust the communications path. The private clients establish a secret with the OAuth server. That secret is then used to authenticate the client during the access token redemption. Refresh tokens or exactly what I described. They're the long-lived tokens. Access tokens expire frequently. Refresh tokens can be stored longer term and can have much longer lifetimes. And basically a refresh token is used to redeem and get a new access token at a later time. This authorization code flow is supported in the technologies that Microsoft supports below. I do apologize. I tried to make this kind of platform agnostic, and I kind of missed a couple things here and there, but just wanted to let you know those are what's supported there. And when I say ADFS VNext, that's both that's ADFS 2016 and above, or 2019. So real quick on the flow, the authorization code flow. You have a user, you have an identity provider, a web application, and an API. So let's say John logs into the web app and the library web app and chooses to show his currently checked out books. So that's request number one. Request number two, library app redirects John to the OAuth authorization endpoint to actually authenticate and provide consent. John does in fact authenticate and grants consent. And then on step 4, the OAuth server redirects John back to the library app with the authorization code. And then on step 5, the library app requests an access token for the book's web API from the OAuth token endpoint. So here the application is saying, hey, I want access to the user's data, and here's my access token. Or here's my code, my authorization code. I need an access token to access the book's API on behalf of the user. The OAuth server returns the access token to the book's API. And then the application then redeems that access token or sends that access token to the book's API to get the data. Okay, client credential flow summary. The concepts is app authentication, not user authorization. The app establishes a secret. The application authenticates with that secret and gets the access token. The user is typically not involved in this flow. The client can perform this flow out of band. That means the client or application doesn't require any user triggers or initiation to perform this flow. So an example of client credentials flow. User John uses a client and address book app. Client authenticates to the OAuth server with its client secret. OAuth server provides an access token back to that address book app. Then the client calls the resource, the web service, with the access token in the header. Okay, resource under password flow exchanges a user credential for an access token. Access token used by app for the API access, primarily for first-party apps. There is some security privacy concerns for third-party apps. Refresh token issued, stored by the app, and it can be revoked. Resource Center password flow. Resource Center user gives credentials to the client. Client uses credentials to request the access token from the server. Authorization server validates the resource owner credentials and returns an access token. Okay, pretty simple. Implicit flow summary used for clients that cannot keep a secret. You see this used a lot in what we call single page applications, or which is basically a JavaScript application within a page. No refresh token is returned. There are some security implications in this flow. That's why not a lot of people use it today. Relies on transport layer security. Access token is then more susceptible to man-in-the-middle attacks. So looking at an implicit flow from a diagram perspective, client redirects resource center to authorization server. Resource owner grants or authenticates and grants consent. The authorization server redirects the resource owner to the client server component with the access token in a URL fragment. Now you're starting to see all the pieces that I did at the beginning as level setting or kind of play into everything that we're talking about here. Client server components returns script that extracts access token from the URL fragment. Okay, real quick, OpenID Connect. OAuth was not intended for authentication. It's purely an authorization protocol. It gets into your question from earlier, Nick. OpenID Connect adds an identity layer on top of OAuth 2. It uses two OAuth 2 flows. There are more coming out, but primarily it uses two. You got the authorization code flow and the implicit flow. Adds an ID token to the OAuth 2 exchange. Adds the ability to request claims using an OAuth 2 access token. It was ratified in 2014. Microsoft actually co-authored that. And not too long ago, I think it was about a year ago, we actually got OpenID Connect certified on the Azure AD platform. Okay, so authentication with the authorization code flow when the OpenID Connect scenario. Client registers with an OpenID Connect provider. Similar to setting up that relationship, even in OAuth, you have that relationship. You have to register or create that trust between the client and the authorization server. So just want to kind of point that out because I realized I didn't say it before. User browses to the web app and initiates login. Web app returns or redirects the user to the OpenID Connect provider. And this is what that request looks like from looking at an HTTP request. User authenticates to the OpenID Connect provider, gives consent for the web app to use their identity. The provider then builds the authorization code, redirects the user back to the web app with the authorization code in tow. And that's kind of what that request looks like from the OP. It's basically a 302 redirect. Web app sends the authorization code back to the identity provider or OpenID Connect provider in a post action. And then the OP creates an ID token and an access token and sends it to the web application. And that's what that request looks like. You notice that you have both tokens types. You have the ID token and the access token, but as you can see, it looks like it's one entity. So in this case, you have an access token with a refresh token. You see their IDs in there, and then they have the ID token, or they're separate, quote unquote, tokens, but they're within the same construct. The brackets, there's only one set of brackets there.
Hey, so Dwayne,
Yeah.
just in the interest of time, we've got a couple of great questions in the chat, so wanted to see if you can address those.
Sure.
And then if there's want to wrap up in the next 5 minutes, and then we'll pass to Matt just so he has time to go through his briefing. So
Sure.
the first question was from Andrew, which is, with SAML being so prevalent, what measures exist to detect, protect, and recover from token forging attacks such as Golden SAML, or this probably applies equally to OAuth, which among things seems to circumvent MFA. So so in all these flows you're talking about, particularly with Azure AD or some of the other Microsoft properties, how do you see people kind of detecting, mitigating, or stopping those sort of token forging attacks?
So in the case of recent attacks where identity providers themselves were breached and token signing certificates accessed and extracted from those servers, to give the attackers the ability to create or forge those tokens, you bring up a good point in that it's very very difficult to distinguish between an actual token issued by the identity provider and one that was forged. The things that you can kind of look at to clue in on is sometimes the attackers are not very thorough when they generate their SAML tokens. There'll be some inconsistencies in looking at the token than what you see off of a regularly issued token from the identity provider. Things such as the authentication instance, some other attributes that exist. Their formatting is got to meet the protocol spec, but some of the data in those statements within a SAML token might not look 100% kosher compared to what they are in a normal scenario. Outside of those inconsistencies, there's not a whole lot you can do to detect that someone has a forged token that was used to access a service. Other than things like obvious client location, things of that nature. If it's an abnormal location, you've never seen that user log in from that type of device from that location before, then that may be a good indication, but it's not a sole indication, because that kind of stuff does tend to happen. And some of those pieces of information can even be spoofed as well. So it's just looking at those inconsistencies, doing everything that you can to protect the key material. One important thing I'll note is anytime you have a PKI-based trust that is used to assert, basically identity information across security boundaries, always use an HSM to protect that key material. That's going to be your best defense against that forging attack. The other methods of forging SAML tokens can be a little bit more expensive for the attacker to do, and it raises the probability of detection significantly. In this case, in some of the most common day attacks that happen, most people aren't using HSMs with their identity providers to protect that key material. So it made it, kind of, I don't want to say trivial or easy, but it made it easier for the attacker to then create those tokens in an undetected way.
Okay, no, that's a great point. And just for those who weren't on our session last week, our presenters shared some great resources which are in the forum talking about kind of hardening on-prem identity systems and on-prem environments against various attacks to the cloud. So the other question that was raised from Justin Felix is, with identity becoming more and more cloud-centric and the synchronization of identity to the cloud Azure AD Connect, do you see Microsoft continuing to support the on-premises ADFS services as much into the future, or is that being phased or migrated to Azure SSO?
That is a great question, and one that has been asked many times over the last couple of years. And the answer really is kind of, maybe, sort of, depends. And I know everybody loves to hear those kind of answers. Of course, we as a software company, we at Microsoft, we always strive to provide what our clients and our customers need. So on-premise identity technologies that we currently provide through Active Directory, ADFS, are going to continue for some time. We would love to see a world in which we can get to a cloud-only, cloud-first implementation. We know that the product currently has gaps that it would need to meet in order to do that. So I certainly say it's a goal that we aspire to, but it's just not there today. Now, timeline for all these things to happen, it could be years before we realistically see the ability for someone to completely cut ties with an on-premise based identity system.
Okay, great. Well, so Dwayne, I want to make sure we leave Matt plenty of time for his presentation, so I don't want to cut you off, but if you want to kind of wrap up in the next minute or so, and then we'll switch over to Matt, and then I know there's a few questions in the chat, so then once we switch over, if you could respond to those in the chat, that'd be great.
Sure. Okay, so what I'll do is I'll just kind of blow through the rest of the slides here really quick. I won't go into any explanation on them. So in OpenID Connect, there's this other endpoint that we created called the user info endpoint. This is a way for applications to make out-of-band calls to get additional claims about a user or different attributes that may not have been included in the ID token initially. It's a REST-based endpoint. Authenticate with access token received from your provider. It returns basically a JWT in response with the additional attributes that the application requested. Not new, SCIM's been around for a while, but it's worthwhile mentioning. It's not an authentication protocol, but as someone mentioned, there's a lot of identity synchronization going on in the world. SCIM was a protocol developed to make it kind of easy for systems to talk the same language when they have to share identity information. We use SCIM heavily in Azure AD when we bundle applications up to allow our users to more easily onboard the applications. This is things like Salesforce, ServiceNow, Box, Dropbox, what have you, SaaS platform. They all support the SCIM protocol. When you're setting up that app, you can basically check the box and say, I want to synchronize user information from Azure Active Directory into this application. And it allows you to scope that as to what users you want to sync and what attributes you want to sync over. Very handy, makes it very simple, doesn't require any agents to be installed anywhere. It's just a checkbox and you're done. And that's just kind of a history of where SCIM came from and all that kind of stuff. And kind of like an overview of the provisioning process. So if a user gets, provision in Active Directory, Azure AD Connect then synchronizes them up into Azure AD. Then you have this SaaS provider or other application that supports the SCIM protocol. Use the admin can configure Azure AD with this application. Basically saying, hey, all the users in this group go over to this app. Those users then get provisioned through that API into the app's identity repository. Simple. Okay, that's all I've got. Thank you, everybody. Go ahead, Nick. Sorry.
No. Yeah, finish it, please.
Yeah, so that's and by all means, this is not meant to be a super in-depth. I mean, we could talk for hours and hours on any one of these topics that I covered tonight. This is meant to be more of a high-level, a description of all the authentication protocols that within use within the cloud. To give everybody kind of like an understanding.
Yeah, absolutely. Dwayne, thank you very much. It was definitely I learned a lot from watching that. So, sorry we got a little bit of a slow start, so you ran out of time, but really appreciate. And I know there's a few questions in the chat, so if you want to take a look at those and respond to them there. And without further ado, we'll hand it over to Matt Nevins from Planet Technologies. Matt, thank you for joining us tonight. Take it away.
Sure. Thanks, Nick. So I was told to just do a quick 30 seconds on myself here to get introed. So I've been working in enterprise IT for almost 20 years now. Some things there you probably haven't heard in a long time, like Novell and Domino, but really through the entire Microsoft stack through that time. Really in the past 10 years have focused on Office 365 identity, on-premises identity as well. And really developed some really complex enterprise identity across government customers, commercial customers, large education institutions as well. And just on a personal note, since we were told to include that too, I've traveled to over 110 countries and really do it because I love the culture and the food and wine when I can. So talking about my topic today, I'm going to start by talking about zero trust. So zero trust is really, of course, a very important buzz phrase these days. It's really become the forefront of how we approach modern security and access. And so when we think about zero trust, we kind of think of it in three different silos or three different steps. The first is signals. And signals are really important because if we just take a sign-in event and don't look at anything else about it, then to us, it's not necessarily as valuable as it could be as all the other data we might be able to collect. Now, what type of data can we collect about that sign-in? Well, we can collect user data and device data, and we look at user risk and device risk as the starting point here. So a user risk might be something like, has that user had impossible travel recently with a failed authentication? So has that user, successfully signed in, perhaps in Portland, Oregon, but then unsuccessfully signed in, or maybe even successfully signed in Russia or another country? Has that user recently successfully been challenged with multi-factor authentication? In other words, have we proven who that user is in a recent time frame? In other words, is that user active? Can we tell that they're actually trying to sign into their account and they're just re-authing, or they've got a token refresh happening? Again, looking at more odd things here, are there unusual locations? So again, through the use of machine learning and AI, we can take a look and say, well, yeah, this user generally logs in from Portland, Oregon, during the week, and then maybe they log in from San Francisco on the weekends. But oh, that's a Monday and they're trying to sign in from Dallas, Texas. That's probably not too important. Oh, but now it's another Monday and they're trying to sign in from Ireland. And so we may use that information to, again, through AI and machine learning, to understand what that user risk might be. And alone, some of these things don't necessarily add up. Alone, they don't really mean much. But as you add them up and increase a user's risk based on those pieces of information, that's where we go and actually start to build a larger, more accurate risk profile for that user. The last one, again, just some of the examples here would be, has that user's password been found on the dark web? And so, going out and actually Microsoft's actually looking at, as well as other identity providers, looking at and buying up passwords off the dark web so that they can contribute them back to their own databases, understand where there might be leaked credentials or stolen credentials out there for sale. So beyond user risk, again, is device risk. And devices certainly can contribute just as much information about themselves back to a sign-in event or a signal. And so we look at things like, is that device managed by an MDM or a provider, such as Intune or any of the other MDM providers out there, AirWatch, et cetera. We can also then look at the compliant state of that device. So just because the device is managed doesn't necessarily mean that it actually has all of the policies and procedures put in place that the organization desires. In other words, is that device encrypted? Has it been recently scanned for malware? Does it have biometric sign-in through Windows Hello for Business, et cetera? And so again, taking these signals as a sign-in event happens, these all go into a security policy engine. And that security policy engine is really what develops the threat intelligence. In other words, when we go to sign in, is that we're doing real-time risk assessments based on the users and the devices, and we can then make a decision based on policy. So a policy might be something as simple as every time a user signs in, they have to use multi-factor authentication. That's pretty straightforward and simple, and should be something that should be at the forefront of most organizations' identity perimeter, which we'll talk about in a few minutes. Or we could also force remediation there. So maybe we do see some of those higher user risk settings like impossible travel and a leaked password. We could, for example, force a password change or lock that user out for X amount of time and create a incident within our incident response system. All of these things can be wired together so that we have a decision, again, whether that user might be breached or, again, perhaps we're allowing them in based on their device and user risk being acceptable. Now, what's interesting is that we also have on the other side of this funnel, really is the way to think about it, we have different resources that users can access. So our traditional thoughts would be around, SaaS and on-premises applications, Office 365, being at the forefront there, but things like anything that supports OpenID Connect or SAML, any application that can be integrated with Azure Active Directory, so everything from Google Workplace or Workspace to Salesforce, Box. There's literally thousands of applications, as was mentioned by Dwayne earlier, that can be integrated in that sense. We can also look at legacy authentications, legacy applications. And so we can look at those signals coming from those as well as access to them, whether those be .NET applications or LDAP, Java apps, all those types of things. And lastly, we look at networking and documents as being our enforcement resources as well. So documents, for example, we might want to allow access to Teams, for example, based on a user's medium sign-in risk. But we could actually use proxying, for example, to restrict their access. So they could be prohibited from cut, copy, paste within Teams, or they wouldn't be able to upload or download content, or they can't. There's other restrictions we can put in place. And so these the risk flowing into the policy engine, into what we're actually trying to access from a resource perspective, all flow together in our zero trust model. You also may hear the term zero standing access. This is somewhat similar, though more focused on administrative uses. But zero standing access basically means just because I have a privileged account doesn't mean that that account should always have access to a resource. I don't have it detailed today here, but that's where something like a privileged identity management approach would come into play, where I actually go in and check out that role. Maybe it has to be approved by somebody on my team or on a different team. And then I have that role, perhaps maybe a global administrator role within Office 365 for X amount of time. And so that's, again, another extension of a zero trust model in that we have zero standing access. Taking a look at how we secure identity systems, identities really are the baseline for what attackers are going to go after these days. They understand the value of having access to identity, whether that be on premises or if you're a cloud native organization, those cloud identities. One of the things that was brought up on our previous call is, you really need to assume breach at this point in your environment and work backwards from that. In other words, we need to make sure that we're monitoring all the different aspects of the identity platform that could be exploited. So whether that's looking at things like pass the hash, golden ticket that was brought up by Andrew as it relates to SAML, but also, of course, applies to Active Directory and other identities providers today as well. Looking at exfiltration of data, credential theft, all these things add up to what really becomes a major breach, because those attacks are automated at this point. It's not somebody sitting at their terminal, somewhere coordinating these attacks using scripts. This is lots of AI, lots of automation on their end that actually go out, will do reconnaissance and find their way through lateral movement across the environment. And while there's kind of two different forms of what happens really in the end, and this again was talked about in our previous session by Steve and Mike and Andrew, is that data exfiltration, and that they hold that data hostage, they hold your identities hostage, or for ransom, or are they actually exfiltrating that data for other reasons? Are they going to use that to perhaps do additional attacks on the environment or on the organization, or is that actually intellectual property data that they're more interested in and don't necessarily need to hold at ransom? And so there are some great resources out there for talking about defending that credential theft, specifically around Microsoft resources, but also the greater approach to identity as a perimeter and identity credential theft, excuse me. And so those can be found there. Again, there's some Microsoft specific items, but also some really good just general best practices around how to approach that, regardless of what your IDP or cloud identity is. So talk about account security and some of the success factors, because we really want to make this as hard as possible for the attacker, right? Now, we say hard as possible. What hits them hard is increasing the cost of it. If it takes more time for them to do it and it costs them more money, they're not going to be as interested, because if your target doesn't change, if your target doesn't become more valuable, they're going to continue to say, okay, well, we'll reevaluate this and go find somebody that hasn't gone down this path. So there's a couple different things we want to think about when it comes to, again, success factors here. First of all, we want to make sure that we have a great experience for users, for your support staff, and for security. This starts with, of course, single sign-on and a single identity. These are pretty prevalent across most organizations that have adopted cloud services today, whether that be Office 365, AWS, Salesforce, all those types of things. We also want to have strong assurances, right? So we want to make sure that we're providing additional factors, whether that be multi-factor, PIV cards, CAT cards, physical devices like FIDO2, security tokens, etc. We also want to increase that context. So this goes back to the data that we're collecting as part of the sign-in, and so the signals that we're collecting. In other words, we want to make the more information we know about a sign-in or about a user, the better the more informed decision we can make. So you see there just, again, some of those things that may come into play there around date and time, geolocation. We mentioned device integrity, and also known bad actors. We also want to make sure we're looking at our behavior analytics. In other words, we know that specific sets of users might do these specific type of job roles. If they're doing something out of that particular normal behavior, that can lead to then kind of increasing that score and understanding that we may need to look at that user and what they're doing. And then again, talking about flexible access levels. So I mentioned this slightly about administrative access, but also it applies really to users as well. And so we want to have users with low friction and low risk. Perhaps we only need to have MFA for those users when they sign in. And if it's on a compliant device that's managed and from a known location, we have a higher level of trust in that or assurance. But if, again, as I mentioned, if we start to increase that user's risk or the device risk, we can start to decrease access or, again, have forced remediation beyond that for high-risk sign-in events. So talking about identity as a perimeter. Identity as a perimeter really has caught wind here the past 2 years or so as a concept, because it really has kind of come to the forefront of how we can best protect the environment. So if we think about the evolution of security perimeters, physical security, we've got our castle, we put a moat around it. As long as you don't have a boat, you can't get across the moat, or as long as the bridge isn't down, we feel pretty secure there. Well, we know that with our way of we work today, and even before COVID, that's certainly something that has evolved over time, to where we may have evolved that over to network, right? So we might have people working from home, they might have to VPN in, we might have remote offices, but still physical and network security there that we thought could be appropriate. But now we've gotten beyond corporate controlled networks, right, where we have cloud-based applications. There's organizations, you probably don't even know how many cloud-based applications are being used in the organization. And so identity then becomes that perimeter, because it's the one thing that's pervasive across all of those applications, is that those users have to get access to them, regardless of where they're at. So if we take a look at modernizing the security perimeter of identity, we kind of see that we've got our on-premises resources that would be inside of our network perimeter. Those might be line of business applications, et cetera. And that network perimeter is established, and we need to understand that even though there's a network perimeter there, we still have to protect those resources just like they were exposed to the internet, because we know that as soon as somebody were to get access to that network resource, they can start exfiltrating data if they have access. So network perimeter, protecting against threats, and those are classic threats and classic attacks, right? But they can be pretty bypassed pretty reliably, again, by credential theft, as I mentioned. Phishing is certainly obviously on the forefront of ways to get into environments today. And so we have to think outside of the box about how we address that. Again, thinking about our cloud and SaaS-based applications, we've got almost every organization is using some sort of cloud-based application, whether that be for things like Office 365, what we call, think about as approved cloud services, ones that are sanctioned. And then there's also things like shadow IT. The number of times that we've, at Planet at least, worked through with customers and identified all of these shadow IT operations that are happening, some small usage of Box or Dropbox, that the marketing department is using, sorry to pick on you, marketing, to exchange data with an external designer because they couldn't do it via OneDrive for some reason. Or they're using, an external expense tracking system or all those kind of things. Determining those shadow IT implementations is crucially important because there's no other way for you to prevent that data that's coming from your internal network to be accessed or moved to that shadow IT environment, or even your approved cloud services. And so again, it's critical to build that modern identity parameter that extends across on-premises, across your devices, across approved and shadow IT cloud services. So again, IAM, or identity and access management, plus the strong authentication that goes along with it. Again, we talked about the signals, and then also taking into account the monitoring that goes into play here. This can't really be understated enough. If we think back to the Solargate incident, one of the ways and one of the vectors that was used in order to move from an on-premises identity to moving to access cloud services was that identities for administrative access were actually synced from on-premises, which is a huge no-no, because of the fact that if your on-prem environment gets breached, then with enough research, those bad actors can then again move laterally over to the cloud side. But on top of that, there were things like OAuth 2, which was mentioned by Dwayne. There were OAuth 2 secrets and applications created roguely, and that allowed more surreptitiously the bad actors to actually go obtain data without kind of causing any alarms. And so one of the things that's really critical to monitoring is things like OAuth 2 application generation, token generation, secret generation. Those are all things that could be monitored via a handful of different services, whether that be Microsoft services or other services. But that's really critical because understanding when there might be that backdoor being exploited is very important. Because for example, a global admin in Azure AD can create an OAuth 2 application that can literally allow access to every piece of data, and going unchecked. You might not have somebody that goes in there and looks at those applications on a daily basis. And so within just a couple of graph commands or PowerShell commands, that bad actor can create that entry point, and it may not be monitored for a long time. And again, net strength from hardware and intelligence. We want to look at those device statuses, et cetera. So just kind of talking about some comparisons of how we control the perimeter and how that information is surfaced to us. When we take a look at this, the network perimeter, we've got several functions. Those are generally kind of comprised of maybe one or two or three devices, whether that be at the firewall, you might have an IDS device, you might have some reverse proxy or internet proxy type device that might be into play. Sometimes they're the same device, sometimes they function outside of each other, but they're generally, kind of an all or nothing device, right? And by that, I mean, they're really an allow or a block. There's not necessarily a ton of intelligence around hosted or controlled applications that are on separate networks or on extranets. You might not get to the same visibility where you might have encrypted traffic if you're not doing SSL decryption. And again, that control is really limited to allow or block. There's not necessarily a more conditional type access allowed in that sense. So as we look at kind of bringing more visibility into that, and you're going to see this is really harkening back to that first slide, right? We're looking at the user and the device. Again, same things around those signals, right? What role that user might be in, their location, where they've last signed in from. Again, device health and integrity. And then again, that conditional access risk as well. And we can do, of course, a lot more things there, even from that simple allow or block to, again, those more covert options of requiring MFA or again, limiting access, et cetera. And those are not only to your intranet resources, through that access point, but also through cloud applications, again, SaaS apps, PaaS apps, et cetera. So just to give a quick example here, again, I think this is pretty agnostic as far as the content goes. I hope it is. So I've got a user. That user, we've got their information about that, who that user is. They're coming in from a Windows device. Their last sign-in was 5 hours ago. We can see they're coming in from a browser. We know that their conditional access risk is going to be pretty low there because we've kind of confirmed that user. But if we add that they're coming from an anonymous IP, or perhaps they were last seen in a different country, or even on top of that, we've seen malicious activity detected on that device through an EDR solution, we can then block access and again force remediation, whether that be on the device, again, whether that be opening an incident, notifying the user, getting a help desk and person involved, because that might require a touch to that user to validate what's going on with them. These are all things that, again, contribute to that higher risk. And again, we'll have that remediation involved. Last thing I want to mention as far as technical things go is there's some great resources around passwordless. Touched on it just slightly, I think, in Dwayne's presentation. But passwordless is really, truly the future. Getting rid of passwords seems to be a personal vendetta from some folks at Microsoft, and I'm all on board with it because the experience is vastly superior. Of course, the threat vector pretty much gets very limited, if not eliminated. And so there's some great reading up on that as well. Maybe perhaps we'll have a session on that in the future. Just a couple of things. Again, these are more personal things that I just kind of thought of that really, if you're looking to think about your environments going forward and how you kind of work towards zero access or zero trust, what you want to start doing is, beginning an assessment of your current identity perimeter. This includes everything from your identity provider to your applications that are currently being used, both cloud and on premises, any policies, both written and technical policies you have in place, and then also the endpoints. And so understanding what your current environment looks like will help you work towards identifying some of these things that may be points at which you can start to pick. Two of them that are super low-hanging fruit for most organizations. Again, this is focusing on Azure AD just because that's a lot of my experience. The first is to disable legacy authentication. We didn't dive into what legacy auth is, but it's really username and password challenge with no sort of conditional access on top of it. There are very few reasons why legacy authentication should still be enabled. And so this is something that's the largest attack vector out there in that sense. And then also getting your users, or at minimum your administrators, but hopefully your users, your end users as well, enabled for multi-factor authentication. That can be rolled. It's not an on or off for the whole environment or whole organization. So that can be rolled and piloted. Definitely recommend starting to do that. And that kind of comes out of creating a plan to enhance your identity perimeter. We want to make sure the end user experience is going to be enhanced as well through things like passwordless. And lastly, the changing landscape of identity is constantly evolving. And so I just urge you to keep up with the technical resources that are out there, both with Microsoft and OpenID Connect aspect as well. There's lots of things changing all the time. And so again, identity being what it is today really becomes one of the more important things you can look at from protecting the environment. And that's all I've got.
Great, thank you, Matt. No, really appreciated that talk. So definitely a big round of applause for Matt as well. And I know we do have, I know we're over time, but I know there were a couple other questions. So if we want to address those first, and then any questions anybody else has, and then we will we'll start to close out here and wrap up the next few minutes. So if there's anyone who, I know Andrew has a question in the chat, which is technical debt is a big problem, especially in the public sector. How can we protect those legacy apps using newer approaches consistent with, or like zero trust or consistent with zero trust? Do you want to speak to that, Matt?
Yeah, absolutely. So I think there's a couple different things there that make sense, right? So one is, looking at most likely those apps are still authenticating to Active Directory in some capacity. They might be using Kerberos or NTLM, But in general, they're probably going to be authenticating to Active Directory, so they might not have a modern protocol. But removing that for a second, there's certainly lots of parts of the Microsoft stack and other providers as well that can look for protecting identities even within those applications. In other words, we're looking at things like domain controller authentication logs and group escalation and ticket hashes and all those kind of things. Getting some of those tooling in place to provide you insights into what's happening is certainly a big thing there. So again, whether it's LDAP, Kuros, LTM, NTLM, all of those things can still be brought into the fold of the threat intelligence silo. Beyond that, if we've got applications that do happen to support either basic auth through web or legacy, WSFed or XAML that are on-premises applications, those can all natively be protected the same way that cloud applications can as well through something called Azure App Proxy. And so they get the same treatment as far as understanding user sign-in risk and contributing that back to the intelligence graph. And so those are two paths forward that certainly exist in the Microsoft realm for kind of addressing that technical debt, at least in an interim. The goal would be, of course, to get the heck off of them. But
great. Okay. No, that makes a lot of sense. So we have another question, and Matt, I'm not sure if you want to take this one or Dwayne as well, but Justin Felix asks, so we understand the recommendation to keep cloud privileged accounts separate. To keep on-premises privileged accounts, and we're doing that within our organization. However, by using cloud-only privileged accounts, we are restricted to using the authentication mechanisms that Microsoft supports or has that Microsoft supports or available for Azure logins. FIDO2 is another option, but our integration team refuses to purchase FIDO2 keys until they've completed FIPS 142-2 certification, and not a single provider has finalized the certification at this time. Is there any way to integrate or allow the federal government PIV certificates to be used for MFA authentication into Azure?
I can take that one, Nick.
Okay.
So there's something coming that's going to be very amenable to your situation, Justin, and it's going to make that story a lot easier. So to answer your question, yes, there is a way, or there's a way coming. It's not there today. It's currently in kind of a restricted private preview. And if you're interested, kind of hit me up after this, and we can talk through that. Yeah, so I think that's about as much as I can say in a public forum, but there is something coming. And as Karsten pointed out, that using PIM is a great way to secure those privileged identities, even if you are synchronizing them and doing federated authentication with them. A lot of the considerations around that from a privileged account use that we recommended not doing the federated scenario or syncing from on-prem accounts is because the ease at which attackers have been able to compromise on-premise systems and compromise those privileged identities and then laterally move with them. This is one more barrier to prevent that. But in the case that you are synchronizing those accounts, keeping them as non-privileged accounts by default, and using PIM to just-in-time enable them with only the rights they need to do what they need to do, is really the a good remediation for that. Hopefully that answers all that question.
Great. All right. Thank you, Dwayne. Well, I know we're way over. So I do want to wrap up here, but I'm sure both either Dwayne or Matt would be, if folks want to continue the dialogue, please definitely utilize our Meetup group. We have both forums and kind of discussion threads as part of each of the sessions. So if folks ask questions there, I will make sure that Matt and Dwayne have get a notice and have a chance to take a look at them. So if please definitely, if you have not already, fill out the speaker feedback form. Definitely very much value your input. And I also want to just briefly, as we close out here, Both extend a huge thank you to both Matt and Dwayne for their time and expertise tonight, and also direct everybody. We have a number of other kind of partner and other organizations that are in the Microsoft 365 community space. So if you're not familiar with these, definitely please check out these resources, as there's a lot of great content and there as well as other communities that are very similar to this one. So definitely the Microsoft Public Sector Tech community is a key one. There's also the Azure Government DC Meetup for those who are interested in Azure as well as Microsoft 365. The Nova 365 MS Users Group, which has existed for a long time and is very active. As well as the Microsoft Government DC Users Group, which is also very active and has some great content and sessions. And then if you're not familiar with some of the folks involved in these, run an On the Spot podcast, which covers many of the same kind of topics and interests. So if you like podcasts, this is a great one to check out from one of our kind of local community members in the DC area. So I want to thank everyone for their time and interest tonight. Definitely please look for some of the upcoming sessions, both the one in 2 weeks, February 23rd, as well as March 9th, and hope to see you all there. Thank you very much and have a good evening.